Hello everyone, I welcome you all to this lecture. In this lecture, I am going to discuss the introductory part of encoders and decoders. In coming lectures, we will discuss encoders and decoders in detail. So let's try to understand what is encoder and what is decoder. Encoder and decoder are two very important combinational circuits. It doesn't have any memory element, but when it comes to encoder, encoder takes some number of lines, so you can say 2 to the power n lines. Encoder takes, so here there are 2 to the power n inputs, the encoder have dot dot, and here as output encoder have n number of output lines. So this is encoder. 2 to the power n cross n encoder it is. Now what decoder does, decoder is just, you assume that the opposite circuit of the encoder. So it takes n number of inputs and generate 2 to the power n outputs. So let's say these are the inputs here, and there are certain outputs. Right? So it takes n number of inputs and generates 2 to the power n outputs. So this is decoder. Right? So there are multiple types of encoders, like we can say 2 cross 1 or 4 cross 2, 8 cross 3, 16 cross 4, and so on. So let's say I'm saying 2 cross 1, right? The in terms of decoders, there is 1 cross 2, 2 cross 4, 3 cross 8, 4 cross 16, dot dot dot. So if I write 2 to the power n cross n, here we will write n cross 2 to the power n. So generally what we do, we use the encoder as the transmitter and decoder we use at the receiver end. So let's try to understand that. Let's say there's an encoder we are having, so it will encode the data. So I'm considering it as 4 cross 2 encoder. There is one input, another input, another input, and the fourth input. These inputs we can name as like 0, 1, 2, 3, right? There are output lines. Let's say this is one of the output line, and there is another output line like this encoder is having. So these output lines, like this is O0, output 0, right? O0, and let's say this is O1. This is 4 cross 2 encoder. So let me write it. It is 4 cross 2 encoder. So we pass any 4 input here and it will convert into the 2 outputs. How it will convert? Actually, when we try to represent any 4 information, we require 2 bits. So let's say we are going to pass 0 0 to the circuit. These 4 information can be represented as 0 0, 0 1, 1 0 and 1 1, right? So the similar thing we will get here. So when this is coming as input, we will get 0 0 here. So 0 here, 0 here. That means input 0 0 was high. This I0 was high, right? Similarly, if this input is high, that is 1, we will get here 0 1. So I hope you are getting. If this input is high, input 2, then we will get here 1 0. And if this input is high, that is I3, third input, then we will get 1 1. So these lines, if we forward, like if we forward this to the other end, then at receiver end, receiver will receive it. So with the help of decoder, so let's say there is 2x4 decoder, which is having 2 input line and 4 output line, right? So this will be connected and this is connected to decoder like this. There are 4 output lines, so this is, let's say, O0, 1, 2 and 3, like this. So once, let's say we have passed here, this is O0, output 0, output 1, output 2 and output 3. So let's say here the sender has set this I0 or 0th input high, then this will circulate 0 0. Once 0 0 will be coming as input, this O2 will become high, or you can say O2, no, it is O0, right? Not O2. This O0 will become high. In case this sender is sending 0 1, then 0 1 will come here. That means O1 will become high, right? So this is 2x4 decoder working at receiver end. So this is the sender or transmitter end. This is receiver end, right? So in that way, the encoder and decoder, they work, right? There are different types of encoders we will discuss, and there are different uses of encoders and decoders. So in coming lectures, I'll be discussing that. For this lecture, it is sufficient. Thank you. I'm ending this.